there's a lot to what the people on this panel do that makes what teachers like I do possible and successful. And I basically love to proselytize teaching with Jupyter as a way to get everybody online, empowered about computing in a way that feels good for them. I'm a teacher. I work with the students. I build curriculum. I love having the tools that these people support, and I really appreciate them. So I'll start out by introducing Colby Bell, who's at Cal Poly, and where there is a branch of the Jupyter family as well. So they have a bunch of Jupyter hubs. I was invited down to Cal Poly this year and went and gave a talk, and it was well attended. People are interested. Things are moving in this space for Cal Poly, and certainly having Colby there to support them is part of them getting a big move into data science.
All right, so I'll just share my screen here. Yeah, so as Eric had mentioned, my name is Colby. I work in the College of Science and Math at Cal Poly University in San Luis. And I'm the server administrator, and I also handle all of the infrastructure for the college as well as the Jupyter deployments. So what I'm going to talk about is the classroom usage of Jupyter, our research usage pretty briefly, and then how we're accomplishing all of this, hosting with Amazon Web Services. And that's what we use as our main leverage to host this whole platform for all of the access. So our classroom usage, there was a couple things that were pretty necessary from the get-go. One was that there was uniformity for each student to access the system. So every time they log in, they receive the same thing that they were expecting. And if they totally break something and they close it and come back, it's fixed. And also that each student saw the same thing. So one student didn't see packages installed that another was missing. After that, there was a guarantee of resources. So if a teacher gave out an assignment that said needed X amount of CPU and X amount of RAM to process, those resources needed to be guaranteed and that those students actually had them so they could run the calculation. And then thirdly was that there was some way to distribute the data without duplicating the data, so that there wasn't multiple copies, hundreds of copies or more of the same data set. So how we're accomplishing this is we're using custom Docker images, and that provides the standardized uniform access that each student sees whenever they log in. We're coupling this with Amazon's service of EKS and EFS to actually do the hosting of the infrastructure. And then to guarantee the resources, we're using EKS to actually standardize the resources each student is given. So maybe they're given 1 to 2 CPUs, 1 to 4 gigs of RAM, whatever the faculty kind of decides. And that wouldn't be able to accomplish that without EKS. So research usage is pretty similar. There's kind of a similar uniformity that researchers like to have. They don't want to sit there and kind of troubleshoot what's going on with each. The shared storage repository is a little bit more important for them just because they want to work on one data set. They don't want to work on, 100 copies of the same data set because that's just, each database is 10 gigabytes, it's 100 gigabytes. So we do the same thing with custom Docker images. The only note is that there's more releases than a classroom deployment, just because the researchers will typically be working on something and say, oh, hey, I need this new package. Oh, hey, I need this. Hey, can you install this? Or can you tweak this, do this? So there's just a couple more releases than a standard student or classroom research release would be. Classroom usage is kind of release one image and then that runs for the quarter. Again, this is being done with EKS and EFS. The resources are a little bit higher for research, typically because they are more intensive processes than just running a simple calculation. And then one note is that autoscaling is not automatic for what we're doing with our research cluster. And that's just so that there's no processes that are killed while it's running. So say there's, a number of pods that are a number of researchers that are logged in and running something and they all close out their system, but they wanted to keep researching in the background. If we had any sort of auto-scaling where it actually killed the nodes in the background, then it would possibly lose their jobs and lose any research they've done. So we have that disabled currently. So deploying to AWS, there's three main services that we use from AWS, and they have kind of, their names are pretty straightforward, at least for these services. They have the EKS, EFS, and then CloudFormation. So EKS is their Kubernetes service. EFS is just an hosted NFS service. And then CloudFormation templates are templates that allow you to define infrastructure. To use these services, there's a couple tools that are additional, which is Eks Ctl, Docker and Docker Hub, and then Helm to actually deploy the application. So this is just kind of a quick visual breakdown of what each tool does to deploy the service. So CloudFormation, you can see that handles all of kind of the base infrastructure. It will deploy a VPC, it'll deploy the cloud, internet gateway, EFS, etc. So that kind of builds your first base. On top of that, after you have your CloudFormation set up, then you can use Eks Ctl to actually build the Kubernetes cluster and have it spin up all those nodes. Once your cluster is created, then you will use kubectl to create some sort of ingress or any other service pods you need. And then lastly, we use something like Helm to deploy the actual application layer on top of the infrastructure. So CloudFormation templates, they are really simple YAML formatted documents that basically allow you to define your infrastructure and then go and tell Amazon to build it. So it takes a lot of the work off. You can just, at any time you want to build the same infrastructure, you just deploy the same template, make a few tweaks here and there, and then it will go and do it. So it takes a lot of the work off of building a traditional infrastructure. It also allows for uniformity so that every time the infrastructure is built how you expected it to be, it's not going to be something weird like, oh, why did this do that? Or why did this do that? It's going to be the very same infrastructure every time, iterated upon with any changes you make. So I use it for creating pretty much all of our resources for the college, but for Jupyter, it's used for creating such things as the VPC, so the actual cloud infrastructure, any sort of networking, and EFS for all of the storage. And the next tool, the Eks Ctl, which actually allows you to interact with or create the Kubernetes cluster and EKS resources, that actually builds CloudFormation templates. So if you get familiar with understanding and reading CloudFormation templates, then it's going to be a tie-in, super easy to use Eks Ctl, and it makes everything a lot easier. One really cool thing about EKS or about CloudFormation is that it allows automatic cleanup. So if you say deploy the stack, set it up, it runs for however long a quarter, and then you say, okay, this quarter's done, I'm gonna start a new cluster. You can just hit delete on that stack, and it'll clean up all the resources it created. So there's no actual management of having to go and tear down all the resources, deprovision everything. It'll go and spin everything up, and then when you're done, it'll tear everything down, which makes deployment and decommission so much faster. And I put a couple links there as far as how simple their templates are, just a couple templates. So Amazon EKS is their hosted Kubernetes service, and it removes the need for a hosting control plane, which in my experience has been very helpful. We actually had both clusters set up previously where we had a EKS cluster and then a self-hosted cluster. The costs were about the same and the management was 0 to null on the EKS cluster because Amazon took care of everything, including, you could do upgrades and all kind of stuff. So it makes life a lot easier, especially if you have a smaller team. They also offer what they call managed node groups, which then removes the majority of the management of the Kubernetes nodes. So now you're taking off the control plane from your management and the actual EC2 nodes. So you have even less that you have to really manage and worry about, but still we'll be getting security updates and all those kind of things. And of course you can make tweaks and changes that you may need for your service. But it's another thing that makes it so if you have a smaller team, a lot of the management is taken off. You can interact with the EKS tool through the web UI, but the Eks Ctl tool is pretty new, but it's very, very helpful and it can speed up a lot of the usage instead of using the web UI. And there's a lot of cool things you can do with it. So you can actually automate the whole creation of a cluster from start to finish using that tool. Once you have the VPC set up and you have everything set up with CloudFormation, you can just send Eks Ctl tool to go build everything for your Kubernetes cluster stuff. The configuration files are pretty simple and flexible. They're fairly well documented, but it's still a newer tool, so there's still some documentation that can be had on that end, but it's still a very cool tool. And again, it's written in YAML. It's a very pared down version of the CloudFormation template, so you kind of have to build a smaller template and then just send that, and then it'll go and build the bigger templates for you. So it's really nice and easy to use. It's very helpful. So our custom Docker images, this is kind of where we create that uniformity for the students. The process is pretty simple. We start with the base image that's maintained by Jupyter, which is great. So we just use the base Jupyter image Docker, and then on top of there we add any changes that need to be done. So we just layer those. So we'll layer base changes, package installation, user customizations, etc. On top of that base image. What that does is it allows us to do offline testing. So we don't have to go into the server and make any changes. We can actually pull the image down, work on laptop or whatever desktop, make any changes, build it, test it, see if there's any problems. And then from there, it can be sent back up to the server and re-released. And using that base Jupyter image, that image is pretty stable. So most of the time, if we need to do any security updates, we'll just do the security updates from the base image, move that forward, whatever, 6 months or so, add any customizations on top of that. And pretty much it's 20, 30-minute process to actually update a Docker image. It's doesn't take very long. And it allows us to roll these images forwards, which is really great. So looking at the cost, the best way to determine the cost is to look at the intended final product and work backwards. So you need to determine how many number of concurrent users and resources guaranteed. And then you can kind of calculate backwards. So in this example, I'm using, say, just for small numbers, 5 researchers, 1 to 2 CPU guaranteeing limit, and then 2 to 4 gigs of RAM, 20 gigs of storage. So you just do some simple multiplication. You can see what the total usage is going to be. And then you can multiply that by whatever your cloud provider's cost is. I'm using C4 and R4 costing, which is a little bit older of a model. They have new C5 and R5 processors. So the pricing would probably be a little bit lower per CPU and RAM, but that's kind of what I was seeing was about that. And then this does exclude the cost of EKS. So this is just the EC2 nodes, but this is using the managed node cost. So you do get all of the Amazon service of basically spinning up the node, servicing it, updates and security, everything like that. So there are a couple ways to lower that cost. So setting up scale down policies. So if you set up auto scaling, you'll want to set up obviously a maximum number of nodes to be allowed, but you want to also set up scaling down policies so that it doesn't infinitesimally constantly scale up to the maximum and then just stay there for the whole month. Otherwise, there's no point. It's not really scaling. AWS reservations are really cool way to save some money. You can say, hey, Amazon, we're going to have this hosted for a year, this type of instance, and you'll get a lower price, which is really nice. And sometimes it can be up to like 40% off of the actual cost of it, usage. And then for storage, lifecycle policies allow for the storage to be moved by Amazon. So they'll move it from their active tier of high intensity, high speed to maybe a lower speed. You can set up like say 90 days, 60 days, whatever, so that storage goes into kind of a colder storage. It's not cold storage, you can still be retrieved instantly, however, but it does allow you to save some costs there, which is nice. So there's just been 2 main issues that we've had with using AWS. The first one was that auto scaling took some time out of the class. So that was a pretty simple one. Basically just figure out when the classes are and then set up scaling policies to scale the nodes beforehand. So if I was to say, the class is going to start at 3 p.m., maybe at 2:50, I would set it up to do an auto scale action, or a scheduled scaling action so that it scales up the nodes to the number that is necessary. The other issue was a little bit more complicated, which was just that when there was because Amazon has multiple availability zones, they can have problems where nodes are scaled into different zones. And because the Jupyter Hub needs a PV that attaches as a physical volume to the node, when a Jupyter Hub pod is restarted, it may restart over to a node that doesn't have that, maybe not be in that availability zone. So the easiest way to resolve that was to migrate it to using an Amazon EFS share. And then the hub is located on the share from there. And then that resolved the issue. So it's pretty easy fix. And that's the end of it for me, Eric.
There's like a lag in clicking on mute. Thank you very much, Colby. That was great. Really practical. Ben Winjum, UCLA, you want to go next?
Yes. I'm going to turn off my video while I'm sharing my screen. Let's see. All right, so my talk is going to be much more of a kind of personal history experience. I won't dive down into the kind of a lot of the technical details, which experts might appreciate, but I'll try and give some experiences that the novices might appreciate too. So I come from UCLA's Institute for Digital Research and Education. And just how I got into the Jupyter scene, my background is in plasma physics. So I came to UCLA to get a PhD in plasma physics. And specifically, I was doing simulations with particle and cell codes, which track the evolutions of particles on the grid using Maxwell's equations. So these are very sophisticated codes nowadays. They're used to publish high-profile articles and run simulations for millions of CPU hours on supercomputing clusters. But simulations that were run in the 70s and 80s on today's hardware can be run in just a couple seconds. And so we realized that these would be very useful tools for students to illustrate fundamental plasma physics concepts to them. So we were trying to integrate this into student classes around when I ended my PhD. And then at the same time, I started working for the Institute for Digital Research and Education, which at UCLA, this is an institute which houses the high performance computing cluster, as well as a range of other computing services and infrastructure. So its mission is to lead a campus-wide effort on innovative research and education on the use and development of advanced cyber infrastructure methods, tools, and services. So it really has kind of a broad scope and goals to facilitate research and education across all of campus, specifically for digitally enabled research. So one of my first projects when I started working with IDRI was to investigate a Jupyter Hub, and I realized that this would be a really good tool for bringing plasma physics simulations into the classroom. So for example, for undergraduates, we didn't want to have them to worry about compiling the codes, installing visualization packages, or even interacting with the terminal command line. Some of the undergraduates had never seen the terminal command line before. So what we did is we packaged all of the compiled software and packages that we needed into a Docker image. And then with Jupyter Hub, we had the students log into a website where they could access the notebooks, and we wrote Python wrappers for the code so that they could run the simulations by executing a cell inside of the notebook. And then we wrote Python wrappers for other of the plasma physics visualization tools that we had developed. So the Jupyter Hub was then good at authenticating users, saving the files, kind of managing the Docker environments for the students that we needed. And this was a very useful tool to enable the students to run this very sophisticated research software. So when I developed the Jupyter Hub, this was on a single virtual machine in the sandbox cluster in the data center. It was a relatively simple virtual machine, 8 cores, 64 gigabytes of RAM. And the first adopter was an undergraduate plasma physics class, which had about 25 students. So this system worked very well for them. As I said, we used Docker containers and Docker Spawner to control the user environment. We used Google Authenticator for the authentication. So this was useful. UCLA has GApps for UCLA, so the Google Authenticator could be used to authenticate UCLA students. The class materials were kind of being developed throughout the class. So we used a pre-spawn hook to copy the materials while they were in development to the students as they needed to use them. And then kind of along the way, I was also getting an education and the necessary computing configurations which were necessary, something like calling idle services, idle servers, redirecting HTTP to HTTPS, and other things like this, which were useful for administering the hub. So in my own experience, once I made it past the initial hurdle, basically I used the straightforward documentation on the Jupyter Hub GitHub repository. I found the Jupyter Hub itself was relatively easy to administer. Most of the work that I found that I had to do was to try and accommodate user patterns, both the patterns of the teachers and the students, in trying to use the hub for whatever way that they wanted to use it. So for my first case, the materials were rapidly developing as class was going, and the Jupyter Hub itself was deployed kind of mid-quarter. So the specifications for the environment were very dynamic, and that placed certain restrictions on us. I found it to be more useful, certainly, to decide what you want to do before class starts so that you can more precisely specify the requirements for your system and provision them as necessary. So important questions such as what computing do you need then help you get around issues potentially with overloading CPUs, overloading the RAM, waiting for servers to start, these type of issues that you'll run into if you kind of dynamically deploy things as the class is running. I also ran into a couple gotchas. For example, if you're trying to make a reproducible environment with Docker, I ran into an issue with the latest tag where all of a sudden the underlying Docker image that I was pulling from changed, and when I tried to update the Docker image, the latest version of Julia didn't run on the underlying hardware, which created problems for me when I tried to use the latest tag. So there were some additional things like that that I had to keep in mind. As I was deploying this virtual machine, I also searched around campus. So there's another Jupyter Hub that's deployed in the Department of Chemistry on their own servers, and one that's deployed in the Department of Atmospheric and Oceanic Sciences. That one is deployed on Google Cloud. Those are used for physical sciences classes and activities for grad students. And then following that, the next class to use it was a computational physics class. This one was fairly straightforward, given that I had already set up the system. Kind of the issue that I ran into with this class is that some of the students tried to install heavy-duty particle physics software related to their research. The code itself was a couple of gigabytes, and ultimately the process failed because there weren't sufficient tools in the environment to do the build. Which kind of made me realize two things. One, that it's nice to have control over the packages installed inside the container, so you can control to some extent what the students do. And it reinforced my appreciation that students can do things that I don't expect them to do. Especially in later Jupyter Hubs, when I have students, several hundred students, a few of them are inevitably likely to do things that I am completely not expecting them to do. The next step was the plasma physics class had ended, but the plasma physics research group was still interested in using a Jupyter Hub. So we took a simple desktop computer that was sufficient to support the number of students that were interested in running these plasma physics notebooks on it. This was deployed just on a simple desktop computer, which had sufficient resources for that intended purpose. The IDRI virtual machine was used for classes and workshops within IDRI. And this information studies class, I integrated NWDSE. So first, just about the simple desktop computer, PIXI is the Particle and Cell and Kinetic Simulation Software Center, which does the plasma physics research. So even though the desktop computer was very modest in size, it was able to accommodate classes and workshops, even those done at external workshops at other universities. But I ran into another realization about computing limitation. So for the most part, the CPU limitations of running Jupyter notebooks are not too demanding because the activity is so intermittent. But with these high performance plasma physics codes, running computationally intensive software like this was not a good thing to do if all of the students tried to run a cell at exactly the same time. So that was one thing that we had to be cautious about. I also realized for the information studies class, when we deployed NWDSE, and both the teacher and I were excited to use this, the teacher kind of quickly realized that it takes a lot of work to make good notebooks. I don't think this is surprising to anybody who's a teacher. And even though Jupyter Hub and Jupyter Notebooks are intended to make it fairly easy to interact with this, it does take a certain amount of time to get used to the software interface and for students to get used to using it. So ultimately, the work was being done too fast at the beginning of the quarter, and the professor's interest ended up petering off within the first week or two, just kind of due to lack of preparation and the lack of time to devote to what it was necessary to run. So there were two next steps. One is that I had left this virtual machine with IDRI open for anyone at UCLA to use, even though it wasn't widely advertised. So there was a mechanical and aerospace engineering class that started to use it. And within the first week of using it, they had quickly maxed out the available disk space, which made me much more cognizant of kind of being more careful with the resource allocations and communicating with professors about the limitations. And then there was a psychology class then that we provisioned a new Jupyter Hub on another virtual machine with a much larger amount of RAM to accommodate a much larger class size. So now we're getting, this was, I should mention, these classes are mainly Python. Mechanical and aerospace engineering class started using Julia, and the psychology class was interested in using R for statistical methods. So that Jupyter Hub was able to accommodate a large number of students with a relatively modest amount of RAM per student. But just as another gotcha, we realize even if you impose reasonable memory limits on students, they can still try to open lots of notebooks at the same time. And if they do this, or if they do it without realizing that they're running lots of notebooks, you can run into trouble. And it's also important to realize the limitations of distributing notebooks which you haven't proofread or which you want to redistribute corrections to. So following this now, we're getting to just last quarter. The virtual machine with a large amount of RAM accommodated 2 more virtual classes since classes moved online. Both the political science and economics class used that Jupyter Hub again for statistical methods for social sciences. And then there was a biostatistics class that used Julia to model differential equations. So the class that was originally the psychology class was part of a larger research initiative at UCLA called the Teaching and Learning Lab. So that that project broke off, and we deployed. Now we've been investigating other deployments, cloud services. So we deployed a Jupyter Hub on AWS for the TAL project. So last quarter, when classes went virtual.
Can you start to wrap up, Ben?
Sure, I'm almost done.
Okay.
So the large classes were able to use these to great advantage. Just 2 notes. One is that we found it useful to utilize the configuration options in Jupyter Hub API to accommodate the virtual environment. And the other is for teachers, it's good to make sure that you do make sure that your students know how to navigate the Jupyter environment. Proctor and test over Zoom is very tricky if you have hundreds of students trying to interact in the chat window at once. So just as wrap up, this is kind of the state of affairs at the moment. We've now deployed the Iterate Jupyter Hub onto Google Cloud instead of virtual machines on our sandbox cluster. So we have continued interest from classes. We're interested in deploying this on the Huffman 2 cluster, which is the high performance computing cluster. And then for the teaching and learning lab, we're also doing custom projects to reach out to external institutions. So for this, we're developing a custom extension for kind of coordinating interactions between students and instructors, as well as doing some API development. So I'll end it there and turn control over.
Thanks, Ben. That's interesting. I want to hear about NB Simple Grader later.
Mm-hmm.
I like how much things are growing. It's exciting. Scary, but exciting. Okay, on to Dave Anderson in San Diego.
All right, let me get my screen up here. All right, you guys see that?
Yep, looks good.
Okay, so I'm David Anderson, the UC San Diego Data Hub Service Manager. So I'm going to start out telling you about some of Data Hub's features, and then I want to go into usage statistics and kind of give you an idea how much money we're spending. So the project went live in 2017. Initially, we had about 12 classes and 1,000 users. And now we have 35 classes and 3,500 users, so we're growing. It's primarily for undergraduate and graduate courses, but we also host independent study projects and researchers and PhD students, but these users will run at a lower priority on our cluster. We've got a single hub, but we support multiple courses. I'm going to go into more detail on how we did that later. So Data Hub runs on our Kubernetes cluster called DSMLP, the Data Science Machine Learning Platform, and it's the primary resident of the cluster. We've got 1 master node and 23 worker nodes, and we use kubespawner to create the Jupyter notebooks on Kubernetes, and we use the zero to Jupyter Hub Helm chart to set it up, so that's been very useful. We host bare metal machines at SDSC, the San Diego Supercomputer Center. The servers have a mix of GPUs ranging from GTX 1070s to 2080s. And additionally, we have some servers on VMware, including our master server. So that'll let us burst CPUs if we need to, but we found the primary constraint is the GPUs. So in total, we have about 1,000 CPU cores, 5 terabytes of RAM, and 120 GPUs. In terms of storage, we've got a 65 terabyte ZFS NAS on solid state drives, and we expose that over NFS. The user directories persist between quarters, so these are going to follow the students through their academic career. We've got a script that calls, we have an enrollment API, so a script calls out to it. And at the start of the quarter, it creates all the users' home directories with their UID. And it also makes some Kubernetes resources for them, such as a namespace, any volumes they might have, and security policy and quotas. And also on this server, we put shared data sets with common data sets, so the users don't need to make a copy of them because they're pretty large. So that saves a lot of disk space. So space is always an issue for us. So we've been using ZFS quotas on the users directories because otherwise, you know, they can accidentally push a ton of data to the disk and fill it up. In terms of the containers we're using, we've got 3 standard ones. We're using SciPy ML for machine learning. Those usually have GPUs on them so that people can like run a TensorFlow. Then we've got a data science container, which is kind of just the standard for, you know, any class that needs Python. And we also support RStudio. We do have a lot of classes that want customizations made to their containers. So we'll create a GitHub form and a Docker Hub repo, and then we'll create a new container based on one of our standard images. And we've also started using custom IPython kernels because some packages, when you install them, it's too much for the base environment and it'll kind of break things. So putting stuff into isolated kernels prevents that. And we've also got an example notebook on GitHub to help users make their own custom notebooks. So to get the one hub to work for multiple classes, we made a modification to Jupyter Hub to read what we call JSON profiles that describe the containers used by a class. So when we set up the class, the professor lets us know what images they need and we'll populate their profile. If it's one of our standard containers, we just have an automatic tool that just makes it form automatically. So you can see here, we can specify which image the class wants. We got a memory limit, CPU limit. We can also do GPU limits. And if we wanted to, we could also put in an extra volume for maybe a data set that's too big for our normal data set server. And so Jupyter Hub can call out to our enrollment API so it knows exactly which classes the users are enrolled into. So instead of logging in and seeing 35 different containers, they're just going to see the notebooks that are relevant to them. So that gets us into the 2 ways we can launch the notebooks. The first is just Jupyter Hub. So you can see this student here is enrolled in two different classes. And the other way is to use the command line. So they'll SSH into a server, they'll run this launch command with their container, and then it's going to tell them your notebook is available here at this address. And it also gives them a shell into their pod so they can just run commands right from there. Some classes kind of like to run that way. So now I'll get into usage. So you can see got an upward trend there. That's good. So last quarter, we had about 35 classes and 3,500 students. This is kind of a breakdown by department. So the big users are cognitive science, computer science, data science, and electrical engineering. And here's kind of how the usage looks for a quarter. So you can see most of the usage is concentrated at the back end here. You can see these big spikes when an assignment's due. But we also have this large amount of like free GPU time at the start of the quarter. So we're trying to get the researchers in there to use that time. And we're also looking into contribute cycles to the open science grid. Here's a look at our expenses. So we initially got $250,000 over 5 years just to kind of build a cluster. Last year we got another 50 grand and we used that on a new GPU box. And here's what we would be billed for power and co-location, but we're currently not paying for that. So we estimate we spend about 64 to 90 cents per hour. So that's actually less than Amazon spot pricing for the GPU instances. So that means we also get the added benefit of we have that free time at the start of the quarter. So I'll kind of wrap it up here. Thanks to the team, kind of a small team. We get a lot of work done, wear a lot of hats. If you have any questions for me or Adam, here's our email. And good luck on your Jupyter Hub journey.
Excellent, Dave. Thank you. That's a really big Jupyter Hub you have there.
Yeah. Yeah, like anybody that wants it, we try and accommodate them.
Yeah, that's awesome. It's usually in the cloud where there's no picture of like the closet full of servers. All right, so we are going to go on to Tannavee at UC Davis. Glad to have you, and I think there's a couple different projects that she's going to tell us about.
Yeah, so let me just get my slides. So today I'll be talking about raising and nurturing your flock, which we like to call our cluster. And it's essentially running Jupyter Hub on a bare metal cluster with Kubernetes. And so my name's Tannavee. I am a recent grad. I study genetics and computer science at UC Davis. And I'm part of the Jupyter team working with LibreText. So before I begin, I'd like to mention some of our partners. So like I mentioned, one of our biggest partners is LibreText, and it's one of the most widely used open access textbook websites. And it recently got a $5 million Department of Education grant to enhance the website. And so a recent contribution that we made to the website was to create a CK editor plugin to create more interactive textbook pages for authors. And I'll be going into this more in detail towards the end of the presentation. Another one of our partners is the UC Davis Bioinformatics Core, and they manage the Genome Center clusters. And they're interested in exploring new tech such as Kubernetes to provide flexible compute environments for their researchers. So I'd like to go over some of our objectives, which is the first one is that we want to create a cloud-based computing environment for classroom use. And so this is essentially to kind of create that bridge between from a more traditional learning environment to something that students can expect to do in research or their work. And so, you know, like previous presenter mentioned, a lot of students are really unfamiliar with using the terminal, and many common packages and libraries for Python and R, other languages that they might face. So it's really, we want to create that environment. And so our long-term goal is to essentially have 1,000 simultaneous users. Another goal that we have is we want to create a cloud-based computing environment for research use. And this is essentially to allow like student researchers or even faculty members to use the custom environment that we create on Jupyter Hub for research. And lastly, one of our third objectives is to make open access textbooks more computationally interactive. So as I mentioned, part of that is done through the CK Editor plugin that we created. And so some of our accomplishments so far is that we've built and maintained a 19-node bare metal cluster. We've set up and maintained Kubernetes, Jupyter, and Binder stack on bare metal. We've developed installer scripts and associated documentation for building on bare metal. And we've created a Docker container with a large set of scientific computing software. We've supported 6 pilot classes using the infrastructure, all which have been done since the start of when we went live, which was last year in June. And we've integrated Jupyter via ThebeLab into LibreText. And we've developed ngShare to enable NB grader use on containerized installations. So some of our statistics so far are, like as I mentioned, we've had 1 full year of service starting from June 2019 to now. And we run on a 19-node in-house cluster located in the Genome Center on the UC Davis campus. So we have 3 Jupyter Hubs. Our primary Jupyter Hub, which students in classrooms and student researchers and faculty members and the large Davis community have access to. We also have our testing/staging Jupyter Hub, which the Jupyter team uses. So when we are making any updates or upgrades to our Jupyter Hub, we go to that to test before deploying it onto production. And then we also have one which we use primarily for specialized workshops to kind of model what users can expect to experience. And then we also have one Binder Hub, which is used for the Jupyter integration on LibreText. And some of our pilot classes that have tested out our Jupyter Hub are like the introduction to mechanical vibrations, chemistry informatics, introduction to geophysics, introduction to data studies. And I'd like to mention that some of these classes are actually even outside of UC Davis. So just to get more feedback, and chemistry informatics, I believe, was at the University of Arkansas. And we've also had 2 classes test out our Jupyter Hub, Foundations of Geophysics and Multi-Body Dynamics. So roughly we have had about 233 users, and the cost was approximately $40K for labor and $30K for hardware, and then utilities are covered in the overhead. So the thing is like this is actually pretty, the hardware and setup is quite minimal. And the great thing about bare metal is that, you know, you have most of the costs taken care of because, you know, you're controlling the setup. So now I'd like to mention our flock, which we like to call our cluster. So this is a representation of an actual flock. So you have your rooster and you have your hen and you have your chicks. And so we like to call some of our servers by these names. So our management node is called the rooster, and then our ZFS, which to some of you who may not be familiar with that term, is called Zettabyte file system, which is our file server, is called the hen. And then our chicks 1 through 18 are our agent or worker nodes. So this is like a really nice brief snapshot of our cluster. And so as I mentioned, we have 19 nodes and we have 2 smart switches, and our ZFS is 57 terabytes. So again, our ZFS is our file server. So some of you who may be a little bit newer to this may not know that a lot of computers go into doing data science. And so you need something to manage and to divide up the resources. So we like to use Kubernetes, and it's an open source container orchestration system, aka it helps manage baby computers. And so we also, for networking, we also use like Calico and Metal LB for load balancing. And then we use Helm chart to deploy services, and you know, we use Prometheus and Grafana for monitoring. So really great thing about our Jupyter Hub is that we're able to provide this really complex environment for the users to experience without them having to do any of the, the dirty work. So we have two main goals for our Docker system, and that's to have a compatible set of popular scientific softwares and to allow users to install software themselves. So kind of as a brief rundown of the features that our Docker image is able to provide is that it's built on top of Jupyter, the minimal notebook. It provides a Python, C++, R, Octave, Sage, and Julia kernels. And we're especially proud of this because, you have users coming from all kinds of backgrounds, some people who may not be quite from a technical background. And so, it's a really easy transition for them to use languages such as R or Python. And then, you have some more experienced users who want to use languages like C++. And so our Docker is, just able to provide all of that. It also provides Jupyter Lab and RStudio interfaces, and it allows software installs through apt and conda. And then it's cached on all the nodes for fast load times. And so, I went through all of that, and some of you may be wondering, I quite don't understand what Docker is. And so our Docker file essentially is basically the recipe that we have. So if you're trying to create like a chocolate cake, you need a recipe for that. And so that's where a Docker file comes in. It's the recipe to create that really complex environment that users can use on Jupyter Hub. So, on the top right, you see like, how one may import packages that they're interested in using. But on the back end, what they may not know is that you have this really complex Docker file that creates this image so that the environment is set up. So this is our homepage for the login for our Jupyter site. And like I mentioned, some of our donors and partners are LibreText, UC Davis, the Genome Center, and the Department of Education. And so if you're interested in anything that I mentioned, today, we have a really great documentation system on how to build a cluster, how to set up Kubernetes on bare metal, and how to set up Jupyter Hub and Binder Hub. And so feel free to visit this repo, and all that documentation is available. Now I'd kind of like to go back to our LibreText page integration with CKEditor. And so CKEditor is an open source, what you see is what you get editor, and it adds a binder button to the toolbar. So the binder button you can see is on the bottom right-hand corner. And it provides a Jupyter cell editor model, and it supports multiple kernels. So the languages that we provide are C++, Python, R, Octave, Julia, Sage Math. And so it'll be soon be backed up by our Binder Hub and our default Docker image. So right now we're using UC Berkeley's Binder Hub, but as we're in the process of making sure that our Binder Hub is ready to be connected to our to the CKEditor plugin, we transition over onto that. So again, if you're interested in any documentation related to this, we've made all of that available at this on the link on the bottom left corner. And so here's some snapshots of what the plugin looks like. You can see all of the languages that we have available on the top left-hand corner. And then the top right-hand corner shows this really streamlined and easy way to use it. And then once authors are able to, mix and match different code blocks that they want to create onto their web page, it creates this really fantastic environment for really effective learning. Because let's say you're a faculty member teaching a subject as complex as data science. You're taking examples from like statistics and computer science and math, and just really trying to combine all these different disciplines together. So it can be really quite complex for students to grapple on. So, if you have these interactive tools, students can kind of play around with it as they're learning and learn and relearn at their own pace. So it makes it much easier to teach complex subjects, especially on an online tool. Sorry about that, excuse me. So on to the next page. And then another project that we have is ngShare. And this was created through a team that joined us this past year. And so you have NBGrader, which is a Jupyter notebook assessment software. Now, the problem with NBGrader is that NBGrader requires a shared directory between instructors and students, but it's not available on Kubernetes. Apologies for that. So the solution that we created was ngShare, and it's a database with a RESTful API running as Kubernetes service in place of an Exchange directory. And so if anyone is interested on reading more about ngShare, feel free to visit the Read the Docs link. So, and yeah, if you have any questions, feel free to visit any of these resources. And none of this would be possible without the fabulous team members that we have, past and present. Yeah.
Thank you, Tannavee. Great set of projects. That's a lot to accomplish in 1 year. Really excited for you guys to, you know, have a bright future here. I really like the LibreText project as well. It's really a fantastic effort. And integrating LibreText with BB Labs, I really think that's exciting. Next up is Yuvi Panda, who hopefully in a panel like this needs very little introduction.
Hi, can people hear me and see me? Cool. Hi, thanks, Eric. Eric really enjoys making me feel like just setting me up to make sure that, I don't know, I feel awkward when starting. Thanks, Eric. Anyway, I'm Yuvi. I'm part of the team that runs all of UC Berkeley's Jupyter hubs. And if you were at the talk we had yesterday, you might have seen some of these slides already. Okay, so this is going to be, I'm going to go quickly through how much it, just a bunch of vanity metrics on how much it costs us, how many people we are serving, and then talk through a little bit about the tools we're using, both from a technical perspective and a social perspective. The numbers I'm going to use are for the last semester, which is spring 2020. Again, we have 10,000-ish students who are served throughout that semester, where the total cost comes to about $3 per semester per student, and we'll hopefully bring that down to 2. And our median daily active users throughout that semester is 2,190. Our maximum was about 4,000 active users each day. You can see that graph here. You can see the weekends. You can see the spring break. You can see the pandemic. And I think UCSD had really good classes numbers, which I really liked, but we have no idea how many classes are actively using our services. And a large chunk of that is very intentional. Guardrails, not gates is saying I really like from the DevOps community, where the idea is you explicitly try to not have an approval process, but just make it easy for people to do the right thing. So basically anyone with a Berkeley account can get access to the, small resource Jupyter hub that people can just use. So a lot of the ways that new classes get on board is, Eric or Keely or someone else who's an evangelist goes and shows them, hey, look at this cool thing you can do. Or in some cases, we have students who use this in one class and then just sort of took it with them to another class when they were TAs or something like that. And in rarer cases, professors come to us directly, but usually It's just sort of like, get in because someone really likes it, and then they convince other people to use it because it makes their life easier. And that is great for the most part. We really, really like it. Every day we find, oh, that class is using it, and we had no idea. And it's awesome. And we also provide more than just Jupyter notebooks. We provide Jupyter Lab. We also have our studio running. I'm going to just have a quick demo here. This is the R Data Hub. Everyone I know who uses R Studio. So just as a way to make sure that we support R as first-class citizen, required we support R Studio as a first-class citizen. Ryan Lovett, who's going to talk about it tomorrow, spent a lot of time making it work properly a few years ago for the stats department here, and it's basically like what everyone uses to run R Studio and Jupyter Hub. So our authentication, as you can see, is through Canvas, which is what UC Berkeley uses for its own LMS, and then you just have R Studio running. This also is basically open to everyone on campus, and while like a lot of data science is still in some ways computer science heavy, and having more R representation here, we have found helps bring more of the humanities in, while in a way that like Python's great and awesome, but just if you look at the map of communities using this, the folks in the humanities, there's definitely a bigger representation of R folks there, and this has been very important for us. And like we have a math class that's using Julia. I think folks have moved a little bit from MATLAB to that for that one particular class because of the specifics of how that works. But we have more of our like core computer science folks coming on as well. So we now support like a full-blown Linux desktop inside Jupyter Hub. So your home directories and stuff are shared. So this is XFCE that's running inside, where you can do all of the things you would normally do on a Linux desktop, except through your browser. And this has been very, very helpful in a bunch of cases. Like one of the Eks classes is starting to use this as a way to visualize some of the data they get back from electronics, oscilloscopes, I think. And all of the software for that is like oldish. It is written to use GUI Linux toolkits, and it's going to take a while before they can all be web native. And in the meantime, this works out really well. And the latency is really good. Like for context, I'm right now in India, and this server is running somewhere in the central United States, and I can completely use it without any latency problems. And that's really, really great. I'm pretty happy with. Again, Ryan Lovett really did a lot of the early work this happened. We also have Visual Studio Code running inside here. There's an open source project called Code Server that takes Visual Studio Code, rips out the non-open source parts of it that ships by default, and then makes it possible for it to be run in a browser. So like this is I don't know if this is a C program that I am running. I have a compiler. I can turn up I can just make it be bigger, and I can just, I think it's called hello.c, right, and then a.out. So you can do like more traditional programming here as well in the Jupyter Hub. And again, this all means you get all the advantages of Jupyter Hub, right? Like it's centrally run, people get guaranteed resources. You don't need to worry about the environment students are in, and they can use this on any laptop they have, which also we have found addresses inequities in that a little bit, because if you have an expensive recent MacBook Pro, your experience in learning is going to be quite different from if you have like a hand-me-down 5-year-old Dell laptop. So this also makes that be a little bit different, and it's quite equitable. Right. Go back. So that's the environment, and for content, we want the instructors to be able to make content whenever they want and distribute it to students without like having any like central points where they need to register with or do something about that. So we generally, like, people use GitHub to distribute content. Instructors push their content to GitHub, but students never see Git or GitHub. And we use a project called NB Git Puller that that lets you do this. I think it was developed here like 3 or 4 years ago, and it has gone through like 5 or 6 names, and it's currently called NWDSE Puller. And I'm just going to show you like an extremely quick demo. So we have so the idea is you encode in a single link a bunch of things. The Jupyter Hub URL you want the person clicking the link to go to. In this case, it is datahub.berkeley.edu, which is our main data hub. And then the Git repository is the repository that has your content that you want to send to the person clicking the link. So I just have a test repository that I want to paste into it. And you can have it open a very specific file. I have an index.iboinv file, and you can open it in any of the interfaces that are available, or Studio, Classic Jupyter App, or something else. So if here you see that it has generated a link. So the general idea, and again, I think if you have gone to any of the other workshops, you've been asked to click a link that takes you to a workshop hub. That is also using NWDSE Puller. So if I just open this link, let me open it. What it's going to do is it's going to go and it's going to clone the Git repository. If I've made any changes locally, it will not overwrite them. It will do a Git merge. And if the instructor has changed like the same file I have, but not the same line, that's okay. It'll just automatically merge it. But if you're both changed like the same line, it'll prefer my version. So we'll set it up in such a way that there will be no Git conflicts. Students will never end up in a state of like, oh damn, I have all these little arrow marks. I don't know what's happening, and my notebook doesn't work. So we put in a bunch of effort making sure that doesn't happen. And if you go back to nbgitpuller.link, which is the URL where this gets to, it has information on this automatic merge behavior and how that works. And it's actually been really great because it means that instructors and other students can just start distributing content, right? Like it's not tied to class information. It's not tied to anything else. It's just like, put it in a Git repository and just give it as a link to someone else. And then this also makes them put it on GitHub, which is actually really good for collaboration as well. Once they get over the initial hurdle of, oh no, it's on Git. We have 10 hubs right now. We can get a new hub up in about an hour. The main data hub is the one that has like almost all the students, but then we have a bunch of them for different reasons. There's a couple of these class specific ones you can see, data 100, 102, prob 140, stat they're all there because they have like more specialized environment needs. Like data 100, for example, there's a PostgreSQL database that is provided to every user who logs in. But also because Jupyter Hub has the concept of admin users who can look into other people's notebooks, which is extremely useful when you're a TA and someone's thing is not working. But if you are a student in one class that's using the main data hub, if you're a TA in a class that's using the main data hub, but you're a student in another class, we don't want you to be able to look at other student stuff. So we had to like separate that out. But in some cases, it's like, the R hub is there, that's a very strong social signaler because, Jupyter and Jupyter Hub still have just like strong Python social connotations. Like I love Python, but like, again, I want to really make sure that we give R like the full due it deserves. So we have a special R hub as a way of just like expressing that. Same with Julia and Eks. And the workshop hub is publicly open for whoever doesn't require any auth that is Berkeley specific. So they can use it for workshops like this or like other workshops, and there's always something like that going on. So now I want to talk a little bit about the technical infrastructure we have. Not super much. Very similar to others, we run on a cloud provider. We use Google Cloud. I absolutely love it. We use Kubernetes, Helm, Docker, Zero to Jupyter Hub, GitHub. This is sort of like at this point, sort of if you have, like a Jupyter Hub that is not on one machine or one VM, and is not using something that your system already runs, like Slurm or something, I believe that this has sort of become like the most common standard large install. If your class is under 100 users, please use the littlest Jupyter Hub to not use this. But if you have more complex needs, then this has become a standard of sorts that has a large enough community of diverse enough people that whatever you're trying to do, someone else has probably already done it at least once. And of course, the proud part is like Zero to Jupyter Hub was what, like we had a bunch of code that ran all our Jupyter Hubs that we then abstracted out and open sourced as Zero to Jupyter Hub, which then eventually became part of the Jupyter community and has like many uses in all the places. Our infrastructure config itself is completely in open and in the public. I'm just going to go and show you a couple of those. I think I had this open. There we go. So this is the Git repository where all of our infrastructure setup happens. So any change in infrastructure, like adding a new package, giving more people admin rights, or anything of any sort is made as a pull request in this repository. So for example, in this case, Chris Piles, who's like an amazing student who works with Eric on a bunch of things, works on a grading library called Otter, and they wanted like a bump on the image. And we didn't have to be involved. They just make a pull request to the environment.yaml that data 100 is built from. And as soon as they do it, it's going to automatically kick off. Like we have 10 hubs right now. Let me see if I can find something else to show. Right, it kicks off like tests. So we know if the image builds or not. And then when the tests have all passed, like someone with merge rights hits merge, and we give them out pretty wide, like very easily, because like if we trust you, we give it out to you. And like the trust is then a social trust, not a technical trust, because then we sort of try and trust our technical system enough that you can't screw up without really intending to. And the social trust is to just check that you're not going to intend to screw up. And that's worked out really well for us, because honestly, like me or Jonathan Felder or anyone else who's like staff on this, we don't want to be responsible for every single change that goes through this. And this has like been like really good for us throughout. If you can see this, well, I have a commit history thing here. So you can see that this is from 2017-ish. So each of this commit is a change that's happened into Jupyter Hub infrastructure. We have Grafana that shows like all sorts of real-time graphs. Eric really loves this. It has a lot of, blinking, moving chart things are always quite fun. This is how it is for the last 24 hours. But of course, I can go back and look for multiple times. Why don't I look for the last 90 days, for example? That sort of often takes a second to come back. You can see these little spinnery things, but you can see that it's a bit spiky. You can see when the semester ended and things just sort of like flatlined a little bit. So we use auto scaling a lot. That's like really where a lot of our cost savings comes back. Whenever this decides it can show us 90 days worth of node usage, you can see it probably go up and down. I'm just stalling, waiting for Grafana to come back. But I think 90 days is a bit too much for it right now. Okay.
Come on, Grafana.
Yeah. Nope. It was not funny. Anyway, let me see. Why don't I move it away from 90 hours to something like 7 days? See if that helps. Seven days. That's better. So one of the interesting things.
There was no one online.
Sorry?
Very few users on some of the hubs.
Yeah. We can also actually see if this comes back up. You can see how the summer classes start and go, and then the workshop starts, and there's a gap where like nothing is happening. So yeah, so you can thank you, Grafana, for not being extremely embarrassing. So you can see that, like, each day like this, like during the night, even in the night, there's like fairly high amount of usage. During semester at night, there's like at least 200 people on all the time.
Oh, wait, there's the workshop. You can see the workshop.
Yeah, you can see the workshop. The workshop is kind of bad.
Oh.
Yeah, Grafana really needs to get better colors. Yeah, anyway. And each of these lines, so we deploy a lot. Like each of these lines, you see the dotted red lines, each of that is a deployment to our Jupyter Hub. And so we have like very high amount of confidence that a deployment is not going to break anything. We often have like 5 to 10 deployments. This is not like something we're fixing as much as like we're optimizing cost. We are like trying out some new features, doing something like that. And we have enough trust that stuff is not going to break, that we can do that. And that's also how we can just let whoever wants to use it, because we put a lot of our energy instead into like cost optimizations and stuff of that sort. And this also helps us when stuff does break, we can line it up and be like, okay, this broke immediately after we did a deploy, so that's probably something of a culprit there, and then go back from that. So, and that's been very helpful. And that's it. This is like a wide team. This is not possible without all these people, but also the broader, wider Jupyter community. And this is just the people who have contributed to the GitHub issues. But there is like such a large amount of people in and out of Berkeley who supported this technically, but also like philosophically. Like in terms of like running this in a completely open source fashion, instead of just like, I don't know, of the many other options like MATLAB or something else that you could go to, right? Like it's been a long multi-stakeholder fight that comes from like different perspectives that has led us to like, looking at pretty graphs on a screen. But I just wanted to acknowledge like everyone in that process, but also Jonathan Felder and Ryan Lovett and Chris Piles and like lots of other people who have done a lot of technical work on this, lots of student involvement throughout the times. But basically, every time someone keeps asking us for stuff, we just give them access and tell them to do it themselves. So anyway, thank you.
Thanks, Yuvi. Yeah, if you guys could all put your videos on, I think now we could just have a little discussion or take a few questions. I have a few questions. And there's a couple of questions in the chat. I guess one question I have is, one question I have is, do you think people abuse it? Like if you just leave open Jupyter Hubs, or if you give students unrestricted cloud, some people would be like, you can't just give away compute, then crazy things will happen. But as far as I can tell, that doesn't actually happen. People use it. I don't know if you guys have comments. Do you see where people use it too much, or?
We have seen, like, I don't think it's too much problem on the CPU side, but we have seen students, if we were to give them 8 GPUs access to it, they might use it for a project that doesn't really require that. So that's why we do limit GPUs.
Got it.
I think instructing the faculty, just letting them know, how to get to the admin page so they can actually see what resources are being utilized was kind of a big change for us. Just knowing that that's even there, so they could go in and say like, oh, who's this person? What's logged in here, or what's going on? I think that was culturally just a big change, was not having to contact IT and say, hey, why is it slow? What's going on? Empowering the faculty to take care of themselves made a huge change, I think, for that.
2 mentions in the chat of crypto mining on Jupyter Hubs.
I
haven't seen that yet.
I have seen web scraping though, which it was just one user, and I kind of got in touch with them to see what it was that they were doing. But
is that more concerned about it being illegal or using up too much compute?
Just using it up the compute.
Yeah. Okay, I have another big question is, how do you onboard the N+1 professor? Like, how do you get the next person on board? This is something I'll just illustrate, like, this is what I do. I operate a little bit sometimes as the bridge between Yuvi and the professors, and I'll go to their office and I'll explain the workflow and the documentation and NB-Git puller. And, you know, there's a range of, some professors they already know Python and they're like, wow, this exists, I can use it, amazing. And some other professors, it just takes a while till they're even getting what's actually happening and just grokking the concept of a server in a browser window. So I would love to just hear from you. What is your procedure for getting professors on? Like, what's your process for outreach, and what's your process for sort of onboarding?
In my case, so a lot of it has been word of mouth. I think communication between professors has seemed to bring in most of the interest. Usually I'll go and talk with the professors after they're interested, just to see what it is that they want to do and to see if they if I can offer guidance as far as what might be potentially useful for them. Another thing is I've just tried emailing departments to see if the chairs or other people in the department know about classes that might be able to benefit from it. In some cases, it's been, I really had to actively pursue people who I thought could benefit from it, because it took a while for me to, I think, to show them what the advantages of using Jupyter were. I don't think, in my experience, it seems like a lot of people haven't, they don't really grasp it when I explain it to them. I have to show them actually what it is, and then they kind of grasp what the benefits are.
For our case, a lot of the outreach that we've done is through LibreText and explaining the advantages that faculty members and their students would have using Jupyter Text, and what the additional value it would provide to their curriculum. And so one such example was something that we did a few weeks ago, where we did a webinar, and that's essentially when we kind of launched our CK editor plugin. As well, we also showed our Jupyter Hub and did a tutorial on what professors can do with the hub and what they can do with the CK editor, which essentially is running off of Jupyter. And so we found that, kind of doing a lot of showcases in which we're using it and showing how other professors and their students can use it has been a really good way to showcase how it can be used.
I'll jump in for UCSD. So we've certainly put Jupyter out in front of the various faculty showcases. We've presented at our Center for Engaged Learning and some of the other faculty groups, but it's been word of mouth amongst our faculty that has really driven most of the interest in using Data Hub. And one thing we do have that simplifies deployment once somebody is interested is we have a common form that all faculty fill out to ask for any EdTech resource for a given quarter, whether it's a computer lab, whether it's software, whether it's maybe something custom within our LMS, podcast, lecture capture, et cetera. And so we have inserted both our Jupyter environment as well as the more technical, just raw Kubernetes backend machine learning environment into that CInfo form. And so we get a lot of interest kind of out of the blue that way. We also get people just randomly clicking, ticking off options, and so we have a bit of a kind of a reverse consultation process to understand. Okay, you're a population biology class. That's great. You're a literature class. Let's dig into what your ideas are. And in some cases, we've had music classes use Jupyter to great effect. But anyway, we found that keeping the door open, allowing them to tick that box, can start a conversation. And in a couple of cases, they've actually made use of the resources, even though they initially were not intending to.
Anybody else got an onboarding?
I can hop in. I'm kind of in a unique case because we have the Jupyter team on campus, which is kind of nice. So pretty much all the faculty know what Jupyter is, at least in the college. But there's not a lot that, all of them have probably used it at some point, but they may not be familiar with it too much beyond what was there. So it's kind of, I kind of bridge the gap, and I don't have the data science knowledge, but I can kind of talk them through into layman's terms of how it can work through, and how they could possibly use it in their class, and kind of give. I have a couple demo hubs set up so we can kind of go through together and see what they think, what they would use, and kind of just, you know, I actually have them, if they have any classwork or anything like that, I kind of go through them with them, what kind of packages are actually there, just to see kind of what would be able to be pulled in.
Very cool. Another question on the chat was ADA compliance accessibility issues. This is potentially a challenge to Jupyter. Does anybody want to comment on how that's come up for your institution? Or any?
It hasn't come up specifically for any of the classes, but in order to get on the approved list of UCLA software, I know it's required to be ADA compliant.
Okay, so we're hoping that Jupyter solves that problem for us at some point. We know that they're working on it. Another question I have is certainly about you know, what's happening right now, this online teaching moment. I'm really hopeful that Jupyter can play an important role in the online teaching space, and for the class that I teach, I feel good about it because we can do a lot of assessment, or not assessment, but like a lot of the work can be done in Jupyter that, you know, we can't meet students and do written work. Do you guys want to comment on how, like, this semester and the coming semester, how is online learning affecting learning with Jupyter? You gonna see it more, less?
I actually think that, yeah, COVID definitely provides this situation where I think we'll see a lot more students and teachers and professors choose to use Jupyter for online learning, because, you know, you can provide a really personalized environment with Jupyter, and it still allows that vigor, and it still allows that, you know, those resources for students to use. And you know, so apologies for the shameless plug about CK Editor, but I think this is really, I think with rise in online learning, you're gonna see a lot more creative ways in which we'll see people integrate, you know, Jupyter with teaching. And so, you know, if you have textbooks that have, you know, these interactive code blocks, and you may not have someone who's sitting in front of you trying to explain, you know, these really complex ideas, but if the resources are really laid out in this very effective manner, students can kind of take their time to figure out and play with the resources that the instructor has provided. And I think that really provides the optimal, like, learning experience when, you know, you have someone give you something, but you can kind of apply what you've learned and see what you can do. And then I think especially with, you know, resources like NG Share, where you have like assessment tools coming up, where you can add on to Jupyter, I think it just makes online learning much more effective.
Thank you. Anybody else want to comment on the online environment?
I'll just say, you know, I think our usage was a little low this last semester, just because I think the transition was so sudden. You know, I think a lot of faculty kind of were taken shock by the whole situation. So I think that our usage was probably a little bit lower than it typically would be. But I think with summer classes and probably fall quarter, we'll probably be seeing an influx of usage.
Yeah, for us at Berkeley too, like, you know, because it all moved quite suddenly. So I think we ended up with a little bit more classes getting onto it, that they had to just like, okay, we already have this, let's get onto this infrastructure we had. But overall, I think engagement was lower just because the world was going to pieces. So we'll see how that pans out. I know that like a lot more classes trying to like get onto this infrastructure now, and like, you know, some of this we are putting up, you know, like electronics classes, for example, like they use Jupyter notebooks, but at some point you have to plug something into your computer physically and do things with your hands, right? Like that's just very hard to do with Jupyter Hub, or remote readers in general. So they're all just figuring out as we go along. But yeah, we definitely expect more classes to be on this in the coming semester, but I don't know if we'll have more people.
Yeah, demand continues to grow, but yeah, I guess my worry, certainly in an intro class like Data 8, would be that there's some need for like some hands-on getting people familiar with things, and then they can succeed. So how do we support users with some interactive lab time? Somebody's helping you code in the first few cases. It's just a question for us organizationally, like how to support the help desk or the video chat or the stuff like that. For somebody who's like just starting out, how do you get help? Where do you go? What do you like? Is it just Google? What's the place? I mean, Colby, what's your learning curve? Or Tannavee, what's your learning curve? Where are you learning what to do?
Like setting up Jupyter and the cluster?
Sort of learning the Kubernetes behind the scenes, the Docker, you know, like.
I would say that, so I can only speak for my team specifically. You know, we, the members that were already on the team and previous members did a really fabulous job of documenting everything. I think that's really important if you want to make your system replicable, and, you know, if you want to enhance it, is to have a good understanding of what's done before. So documenting everything. And I think, because, you know, site reliability and, you know, setting up Jupyter and all of that, you're kind of wearing a lot of hats. And so I would say to be really patient and, you know, don't be afraid to Google things. It's not, you wouldn't be dumb to, you know, what is Kubernetes? What is Docker? Everyone kind of has to start there. So really reading the docs, Googling things, you know, asking people, it's just a matter of patience and practice. So I think really having a good understanding of the entire system takes some time, but once that happens, troubleshooting and enhancing and all of that comes much easier.
Yeah, I'll say that, you know, when I started, there wasn't much documentation for the infrastructure that was there. Unfortunately, there was kind of an infrastructure that was set up. And then it was like, here's this application. This is what people use. And so there was just kind of, there was a pretty steep learning curve when I first started. The 0 to Jupyter Hub, like that doc, I think I read that thing, a number of times through for sure. Getting started there was really helpful. And then just really making, Jupyter letting it be the application layer. And then just designing all the infrastructure behind it, however, whatever infrastructure you have. If it's going to be bare metal, hardware, VMware, AWS, GZ, whatever, letting that infrastructure, let those tools build whatever your infrastructure is going to be underneath it. And then just let the application layer sit on top of that in the easiest way. So a lot of Googling for sure, though.
Ben, Adam, you want to comment on where you go for answers?
Yeah, well, I would say I just want to point to the documentation that both the Jupyter project and what has come out of Berkeley in terms of 0 to Kubespawner, 0 to Jupyter Hub rather, 0 to Jupyter Hub rather, littlest Jupyter Hub, and even I mean just the the online fora within the Jupyter website has been really helpful. When we were first getting started, the Gitter that was a pretty good forum for posing questions.
This is the discourse.jupyter.org.
That is correct. And then I don't recall where the Gitter, which is kind of the Twitter/Slack analog for the Jupyter project, is located. But that was also when I had a quick question. There were a number of people that were there ready to help.
Great.
Yeah. Other than the broader Jupyter community, because so many of these stacks are now just built on like quote unquote industry standard systems that are not bespoke and have like very wide usage outside academia. Both like even just looking at KubeCon videos, for example, or DockerCon videos, or interacting with those communities has been very helpful. And they have millions and millions of dollars are being poured into those companies from elsewhere, and like it's great to just write on that as well.
Okay, I got one more question, and then you guys could ask each other questions. My other question is like, where do you see the future? What's the next thing? Like, where are we building this towards? In some ways, what's happening right now is we're building a huge user base. We're building a lot of classes. We're getting interest. We're getting faculty involved. We're building this, institutional capacity that's you guys. The tools are online for us to access, cheap cloud. Where do you think this is going? Like, where is it headed towards? What should we aspire to? Colby, what do you think's next?
I'm not really sure. I think a couple of those tools that I saw that Yuvi had put out were really cool, like having just VS Code directly built into it, or having the desktop directly built into it. That was, it's really cool, and I think that's going to allow a lot of moving off of standard hardware, like dealing with, oh, this student is issued a 5-year-old laptop that has a spinning hard drive. Let's move all of that off, move all of our physical labs off to something more virtual. You can have a full desktop there. You can, if you wanted to run an application like Mathematica or MATLAB, whatever, you can run that inside of the Jupyter interface, and then you can process the data, separately through a notebook or et cetera. So I think that kind of stuff's really cool and neat to see, for sure.
Dave, San Diego, what do you think the future holds?
Yeah, I think it is going to move in that direction where the physical labs are going to be phased out. And we're probably going to see some kind of commercialization in this space where if you want Jupyter Hub, you just pay somebody a monthly fee.
Well, that's definitely happening in the workspace. It's unclear whether that's going to happen in the EDU space. But there's definitely questions in the chat about that. Tannavee, Ben, you want to comment on the future?
One thing that I see is so some research groups have online materials that they're developing, which are intended for kind of multi-institutional use, but they try and integrate a Jupyter Hub as a part of that. So the Jupyter Hubs could be integrated into these maybe online textbooks, or I guess maybe Tannavee is, it sounds like it's similar to her project too. So something that's more just like an online learning resource, which might not be tied directly to a specific university, but which has requires some kind of Jupyter Hub support to go beside it too.
Yeah, I definitely agree with all of that. And I think more so too, because my background is actually also in genetics. So it's really interesting to see, combining these separate disciplines. And I think that will happen more. This just goes more into how teaching and learning will change. I think we'll definitely see that more, especially with the kinds of pilot classes that we're using our Jupyter Hub. They were like in chemistry and geology, and so I definitely think we'll have classes that aren't even data science or statistics or computer science, like more along the lines of like genetics or psychology, and using more computational tools to combine research and learning.
Yuvi, so would love to just toss this question to you. I mean, there's a lot of people asking about real-time collaboration. Like, when will people be ever able to collaborate on a notebook? There's a lot of people asking, like, well, will it be inside Canvas? Will I just see my homework inside my learning management system? Sort of like integration of Jupyter into like other places that students are accessing, sort of computation will be sort of nestled as a nugget inside to the places that people are accessing curriculum.
Yeah, and I think the spaces like that is where like LibreText and the work they're doing is, like in some ways, like, like Jupyter Hub is more than Jupyter, because when people say Jupyter, they mean Jupyter notebooks most often. But like, I'm not just talking about our studio and stuff. Like, I really like LibreText because for the people, for the end users and the students interacting with it, you have no idea. Like, the word Jupyter does not exist for the most part, right? Like, it is whatever it is that you are doing, that is some interactive execution that's happening there. And you're using the technology that was developed by the Jupyter project for the Jupyter community being used in this fashion. But like it's separated out. And I think there is a lot of stuff that's happening there. And in some ways, I feel like, like us people who run Jupyter Hubs are like the wrong people to try and figure out what comes next. Like, I feel like it's going to come from the people who are using this much more so than us. So like, for me and the other people I work with here, it's like the important thing now is to just like empower people even more, and like just like hand out candy some more and be like, yeah, sure. Like, basically just, say yes by default to more things, especially when you don't understand why they would ever want to do that. Just like an understanding of like, yeah, that's okay. Like, I would not, then like they might. But there's also, like, to go back to the other stuff, like, like, oh, can I see this inside Canvas? How do I integrate this? Some of this is also just like a lack of resource problem, right? Because there's like many ideas or projects that work very well where someone has built it in such a fashion that it works for their university and their use case. That would be amazing when it is like more generalized. And in many cases, they would have actually even open sourced it. But you need more resources to go into the ecosystem to like be able to build that. And I think this is where I think in some way this space is sort of at like an interesting inflection point, because open source in general, a lot of money and resources have poured into it from industry, which has like different, like, like it's different incentives for what kind of projects it supports and why it supports them. And like, like the academia isn't really quite caught up in the same way. I mean, it makes sense. We don't have like millions of dollars lying around in the same fashion. But I think like seeing how much like just resources and money is going to be spent on more dedicated stuff here over the next year versus how much of that is going to be spent on, like, say, just buying services from companies that are providing proprietary things, right? I feel like this is another inflection point similar to what might have happened like 10 years ago or so. And seeing also, like, companies provide services based on Jupyter Hub and Jupyter, and a lot of them contribute back to the ecosystem, and some of them don't. And like there is effort being put into making that better so that it goes back into the commons, so that more and more people can use it. So I like, sure, there's lots of new technical things coming on, but I think there's just like a broader recognition of like just the social factors at play, at that we are not all, like, one of the great things is like, we were all like, if you looked at all the tech we were talking about, we are like in different places doing different kinds of things, but we're sort of using the same 6 things, across the stack to do that, right? So like the challenges we have are, sure, there's lots of fun technical things to do, but like, the jump up is always just like is going to be completely social. So anyway, more money to open source people is really the answer to all of this, I think. So if you can advocate for more resources in your university in terms of students, in terms of like staff, just people time, right? Like that can go into projects. To me, like that is what will come out. That is what really will determine how this is going to be in a year or so.
I mean, it's a great point.
I sidestepped completely the real-time collaboration question because I don't want to answer that.
It's fine, but I mean, it's a great, Docker, Kubernetes, like those aren't Jupyter Hub. Those are their own ginormous projects, that Jupyter Hub's just standing on top of them. I have to jump off because I got to go to the next panel. I will leave you guys in here if you want to keep chatting or, connect or look through the chats. Yuvi, there's one question in the chat about NB Git puller, and it might be worth just taking it on. Kate, it's a few pages up, and Kate's asking, it's a little bit about that, like, what do I do when I don't want something to be overwritten, or when I want a new copy, but I want to keep my existing copy, or, briefly, I want to say thank you so much to everybody for participating. I think for me, it's been really interesting to see all your perspectives and all the different scopes and scales and different places that people are on this journey. I, as a user and a professor, I am super grateful to all of you for the service that you provide us, and you're making education better. And we're making awesome curriculum standing on the awesome infrastructure that you build for us. I think it's a really exciting space to make, university education better and more accessible if possible. I also want to make the announcement that there is a workshop tomorrow morning with the commercial providers. Microsoft Azure will be there. They have a bunch of interesting things going on in this space. Google Colab will be there. DeepNote will be there, and DeepNote is worth checking out. They have a very elegant real-time collaboration. And Vocarium will be there, and they have provided Jupyter Hub for Cornell to teach Data 8. So they're like, this question that people are asking, like, can I just buy the Jupyter Hub set up for me? So if you're interested in the commercial solutions, come check those out. There's also another panel on Jupyter, as I mentioned, that will have several new innovations, some of that Yuvi's already talked about now, but also the Jupyter book that's Data 8 is based on, Autograder that Data 8 is starting to use. So come to those panels as well. I got to jump off. Thank you, everybody. I really appreciate your participation. You can stay on if you want to answer a couple more questions or look through the chat.
Yeah, I'd just like to say thanks to the presenters. We've already got a chat going on Slack where there's like 3 different things we want to try out based on this.
Agreed. I have stuff that I need to go test now.
Yeah, this is great. Thank you everyone for coming. I have a request, which is that if possible, like it would be awesome to have you all write up both your setups and your experiences. I would love to just have that published on the Jupyter blog, because I think all that we heard and saw here was very valuable, and it would be great to put that out there.
Sure.
Awesome. Yeah, I'll get emails from Eric and make a follow-up.
Great. Cool. Well, it doesn't seem like there's any questions kind of coming through.
No. Well, I have vague questions. How often do you like deploy? This is always something that I've been interested in. Like just frequency of deployments. Like, do you wait to see if there is nobody using it before you deploy, or?
We'll usually do our big upgrades during the week between quarters. So that might be when we upgrade the Kubernetes version. And we're also using something called Helm file, which is just, I don't know if you've heard of that, but it's a thing that works with Helm just to deploy a bunch of charts.
Yeah, I think pretty much all of my infrastructure is written on YAML. So it's pretty easy to kind of just tear it down and rebuild it when need be. And EKS is kind of, I feel like it's cheating almost, since you can just like push a button and then automatically update your Kubernetes cluster. And if you're using the managed nodes, it'll respawn all of your nodes and re-get them with the highest AMI. So all your security updates. So it's like maybe 5 to 10 minutes of downtime. So it's kind of like, I usually wait for, the big class that will be using it and then just make sure they're all off and then just push the button real quick and you're good to go. But it's usually on something like a, 3 to 6 month time schedule. I try to stagger them based upon when I'm doing new images. So I'm not doing more than one change at the same exact time or same week. So there's not a big impact to the class.
Yeah, we do a lot of our changes during breaks as well. So around spring break or right now, because there aren't any users since we're at summer vacation. In terms of like updating our say development environment, we try to do that in the evening time or really late at night if it has to be done during the quarter, so that the fewest number of users can be affected.
I'll do mine late at night as well. Usually it's relatively frequent, not on the weekly level, but maybe like once or twice a month.
Cool.
I've got a question here from chat.
Ooh.
But it's being covered by emoticons. There we go. Do you have the ability to provision a specific set of resources to specific users that have those permissions? For example, I need 6 GPUs and a specific database node. So we actually do have the ability to, in our JSON format, to have a specific file for a specific user to give them a particular image with a particular set of resources. But as far as giving them a database node, I'm not quite sure what you mean by that.
I wonder if they mention, or if they're meaning like a specific, CPU this or CPU that, which specific physical node they're getting attached to.
Yeah, we do let people pick their node.
Okay.
We actually don't have that. We don't have our profile stuff published, but that's something I could look into. It's basically we went into 0 to Jupyter Hub, and you can add those. Like, you can basically add in arbitrary Python code that's just going to be put onto the hub. So that's how we accomplish that.
We do some tagging with inside of Kubernetes. So we'll tag specific nodes, and then inside of the Helm chart, we can actually point where certain pods will be spun up. So we've done some of that. So that might help as well. You can say like only deploy to data, servers tagged as database servers, or something like that.
Yeah, that's something we've been looking at. Is like, if a user wants a particular brand of GPU or something, like give them some way to kind of get preferred over to those servers. And also maybe if you're using just a CPU, maybe don't use our GPU servers to free those up.
Yeah.
Yeah, you can go ahead and send me an email, Jason. Well, might be time to wrap things up here.
Yeah. Cool.
So.
All right. Thank you, everyone.
Yeah,
Yeah, thank you a lot, guys.
Thank you.
Bye.